All right. Good morning. Welcome to chemistry. Let's go. All right. So here, we have limiting reactant problem. So we're going to be determining the limiting reactant between sodium oxide and aluminum fluoride. We have two amounts, 11.2 and 8.8. So the first thing we need to do is determine which product we want to convert to. So we have to convert to one of the two products. If we go back to the balanced equation, um, so if we go back to the balanced equation, we just need to convert both of these into one of the products. So this is going to be a two-part problem. So I need to convert this one over into one of these and convert this one into the same one. Here, this has 5 atoms, so this is just simpler for me, simply because it has only 2 atoms. So it's just two elements. So I choose this one just because it doesn't have any subscripts on it. And now I'm going to convert both of these into moles of this. Once I get into moles of this, then I can compare. All right, let's take a look. All right, so nothing difficult. We're not going to start off with any chemistry or any mathematics. All we're doing is copying and alphabets. So copying is just like we used to do, or matching in elementary school and in preschool. Alphabets is kindergarten. So no problems here. Easy peasy. Copy the given, draw my T chart. All right. So I haven't done any chemistry yet. I haven't done any mathematics. All I've done is copying and alphabets. If you can draw a T and you can copy, you can do this. All right. So the next step is still the same. I'm filling in the units. If you can copy and you know where to look, it's really easy. So these units always come down. I always draw an arrow every single time. They'll never get me for this. Once I get the units in place, then it's just a matching game. This will happen every single time. All right, and then now I need to go to my unknown. I want to check and make sure, is this good chemistry? Is this something I can do? I can go from moles of one element or compound to moles of another element or compound, no problem. We can use the balanced equation for that. All right, and then now we'll just look at the balanced equation. So from the balanced equation, this is 6. And then 6. And then ALF3 is going to be 2. Na2O is going to be 3. All right, so no problem. It's pretty simple. Now the next step is we're going to do the mathematics for this one for my units. So this is going to be mole NAF units. No problem, easy peasy. All right, and then now the next step is just going to be to do the mathematics. So I'm just simply looking at fractions. That's all I'm looking at. So in this, I don't let this confuse me. I'm looking at a fraction, 11.2 times 6 divided by 3, 8.8 times 6 over 2. All right, so this is just two fractions. So for two fractions, I just multiply my numerators. So this would be 67.2 divided by 3. This is going to be 8, 5, 4. This would be 2. All right. And then now we get our calculator. Let's get our calculator. I think this. So this one is 22.4. And then this one is going to be 26.4. All right, so now we know the amount of. I think about this as like sandwich production. So this is just some product, something I produce. I can take bread, meat, cheese, lettuce, tomatoes. Those would be ingredients or reactants, and then we can have a product. So this is what we cooked up in the lab. This one can only make 22.4. This one can make 26.4. So this is going to stop the reaction. We just don't have enough to reach this amount when we're dealing with sodium oxide. So sodium oxide, this is going to be my limiting reactant here, simply because he makes the least amount of product. This one will be my excess reactant because he has a lot extra. He can make 26.4, but we don't have enough of this one to do it. We only have enough to make 22.4. The reaction will stop here. Stop that one.